Hello. Good afternoon to you all once again. Hi. Please, I would like for all of us to move to the front row seats while we try. Immediately I moved to the front seat and he gave me $20. So I never miss. So what will I give? My wallet is not here. Unfortunately. Unfortunately, my wallet is not here, so. But you never know. You might see car keys under the seat, too. Eh? Okay. So before we start the next session, I would like to find out how the previous session went. So, one word for the previous session. You can just shout it wherever you are. Interesting. Okay. We have an interesting here. Insightful. Double I. Innovari. What? Strategy. Okay. Strategy. Interesting, insightful, strategy. What else? Sorry? Novel. Okay. Any word? Oh, don't be shy. Just mention the word. Sorry? Beautifying. Digitized. Nice. Informative. Okay. Last 3 words. Then we continue. Those on the wings of the plane. Let's get the 3 words from us. Any word from here? Did I hear a word? Okay, any word from here? No word? Going. I'm going to this side. Maybe that side they don't like me, so I'm coming here. Any word from the previous session? Transformation. Fantastic. Culture. Digitalization. Okay. Sorry? Agile, yes. All right. Thank you very much. So, on to the next session, we'll be talking about artificial intelligence, not ChatGPT. Artificial intelligence in general. Then from there, we would have another team to talk about Internet of Things, that's IoT. So who is interested in artificial intelligence? I am. Okay. So artificial intelligence is bigger than ChatGPT. ChatGPT is not the only AI thing that is happening. So we have Mr. Kofi Yeboah, who will be coming here to... Sorry, did I just say Kofi Yeboah? Today I'm butchering people's names. Mr. Fred Yeboah, who is coming here from Kofi Annan to come and tell us more about artificial intelligence. So with a huge round of applause, let's welcome him as he comes here.
Hello. Good afternoon to all of you. And I believe you are having a good time. I'm told that today is capacity building day, and most of you or all of you will be having some hands-on training in AI-related programs. My task here is much more straightforward. I've been asked to speak on artificial intelligence. Without wasting much time, I will deliver my speech, and after the speech, if you have any question, I will take them. So, distinguished guests, colleagues, and all gathered in here. My name is Fred Yeboah, and I work at the Ghana-India Kofi Annan Center of Excellence in ICT. I head the Research and Innovation Department. I am delighted to be part of the inaugural National ICT Week and to have been invited to speak on the topic of artificial intelligence. To provide context, I have titled my speech, AI for Sustainable National Development. In my presentation, I will endeavor to explain why AI is essential for Ghana's digital transformation, discuss potential pitfalls that we need to be aware of, and suggest key actions we can take to fully leverage the benefit of AI. As we gather to celebrate National ICT Week, let us turn our attention to a technology that has the power to reshape our nation, artificial intelligence. Once confined to science fiction, AI is now a tangible reality, transforming industries, societies, and economies worldwide. In Ghana, AI offers immense potential for national development. It can address our pressing challenges, improve public service, and create new opportunities for our citizens. From healthcare to agriculture, transportation, and education, AI has the power to transform every aspect of our lives. Artificial intelligence, or AI for short, is the creation of intelligent systems that can reason, learn, and act independently. These systems, often called agents, interact with humans or other machines to assist, to augment, and even replace human capabilities in various fields. What sets AI apart is its ability to operate autonomously. AI systems can make decisions and take actions without constant human oversight. They can also learn from data and experiences, becoming smarter and more efficient over time. Furthermore, AI system possesses the power of reasoning, allowing them to solve problems and make informed decisions. This capability, combined with their ability to learn and act independently, makes AI a valuable tool for various tasks, from medical diagnosis to climate modeling. Hence, an indispensable topic for any meeting regarding driving digital transformation for a nation. Why should Ghana focus on AI development? Artificial intelligence offers transformative potential for developing countries, such as addressing critical challenges and driving sustainable development. By such development, By leveraging AI-powered solutions, Ghana can enhance agricultural productivity, improve healthcare access, optimize energy consumption, and streamline government services. This technological leap has the potential to bridge the digital divide, create new opportunities, and improve the quality of life for millions of Ghanaians. From my perspective, the following are the reasons why Ghana should intentionally pursue AI for national development. For economic growth and job creation, AI has the power to revolutionize our economy. By automating mundane tasks, we can free up our workforce to focus on more creative and strategic endeavors. This increased efficiency and productivity will lead to cost reduction and improved outcomes across various sectors. Moreover, AI fosters innovation, enabling the development of products, services, and business modules that can drive economic growth and create new opportunities for entrepreneurs. For improved governance and public services, AI is a powerful tool for promoting transparency and accountability in government. By analyzing vast data sets, AI can identify patterns of corruption and inefficiency that may otherwise go unnoticed. For example, in Brazil, the World Bank's governance risk assessment system, called GRASS, uses advanced data analytics to detect fraud, corruption, and collusion risk in government contracting. Similarly, China's zero trust system leverages machine learning to predict the likelihood of public officials engaging in corrupt practices. These examples demonstrate how AI can empower governments to detect and address corruption, fostering greater transparency and accountability. For public service delivery, AI has the power to transform public service delivery. By optimizing processes and reducing costs, AI can make government services more efficient and accessible. In Singapore, AI-powered chatbot called Ask Gemini demonstrate how AI can streamline interactions and provide citizens with valuable information. In healthcare, AI-powered diagnostic tools can revolutionize disease detection and treatment, especially in rural areas. Ghana's partnership with Zipline International, which uses drones to deliver medical supplies, highlights the potential of AI to improve healthcare. And just some few days ago, I was even told that that same system was used to distribute exams papers and elections papers. On the educational front, AI has the power to revolutionize learning. By personalizing education, AI can tailor learning experiences to individual students' needs, leading to improved outcomes and better preparation for the future. In fact, I envisioned a Ghana where a parent will receive a timely notification for education from the educational authorities about their children's upcoming enrollment. And these notifications normally will come with clearer information about nearby schools and registration procedures and necessary documentation so that you can take your child to school. And also to make sure that government is aware that every child is going to school. For sustainable development, climate change is a pressing global challenge. But AI offers a glimmer of hope. By optimizing energy consumption, improving resource management, and developing sustainable solutions, AI can help mitigate the impact of climate change and build a more resilient future. In the realm of agriculture, AI is a game changer. By leveraging on AI-powered technologies, farmers can enhance productivity, reduce waste, and ensure food security. The Indian Agricultural Research Institute use of AI to predict crop yields is a testament to the power of AI in agriculture. For competitive advantage, AI offers developing countries a unique opportunity to leapfrog traditional development paths and become digital leaders. By embracing AI, Ghana can modernize its economy, improve public services, and attract foreign investment. Countries like Estonia and Rwanda have demonstrated the transformative power of AI by investing in AI. These nations have created a more attractive climate, fostered innovation, and improved the lives of their citizens. Despite the numerous benefits AI offers, developing countries must carefully consider several key challenges. First and foremost, we must address the digital divide. And yesterday, for those who came here, you saw what GIFEC is doing to bridge this. Ensuring that all citizens have access to the internet and digital literacy training is crucial for preventing AI from exacerbating existing inequalities. Second, we must invest in developing local AI talent. By nurturing our own AI experts, we can reduce our reliance on foreign experts and build a sustainable AI ecosystem. Finally, on the challenges, we must address ethical concerns surrounding AI. It is essential to establish guidelines and regulations that ensure AI is used responsibly and avoid unintended negative consequences. And I believe DPC is also doing this. That is Data Protection Commission. A study by McKinsey Global Institute found that AI could boost global GDP by up to $13 trillion by 2030. However, according to the same study, developing countries like Ghana may not fully reap these benefits due to our lack of AI experts and infrastructure. Further, according to AI Startup Mapping in Africa report by AfriLabs, Africa AI startups are demonstrating exceptional focus in various AI fields, which is crucial for addressing the continent's unique challenges. The report highlights that 30% of AI startups in Africa specializes in machine learning, followed by 17% in deep learning, followed by 15% in natural language processing, followed by 12% in computer vision, followed by 10% in generative AI, and reinforcement learning is 9%, with robotics being last at 7%. According to the report, the specialization is pivotal for driving innovation in sectors like health care, finance, agriculture, where AI significantly enhance outcome. So what do we need to do as a country to take advantage of AI? And this I call it a call to action. I humbly propose 3 key areas that demands our immediate attention for sustainable AI development to drive digital transformation in Ghana. First is developing digital public infrastructure for AI. To build a thriving AI ecosystem, we must first establish the foundational blocks. This includes developing identifiers and registers, and you can all bear with me, the national ID, has made a lot of difference. Civil registers, health facility registers, and educational facility registers, as well as secure data sharing platforms. Singapore and Estonia, again, have shown us the way with their successful data marketplace and data sharing platforms, respectively. Next, we must invest in broadband connectivity. To ensure that all Ghanaians have access to the digital world, this must be done in a hurry. But TV white space technology offers a promising solution to bridge the digital divide, as demonstrated by the research and pilots that the Kofi Annan Center has already undertaken. Furthermore, in order to foster innovation and collaboration, we must promote open data initiatives. I dare say that we need to enact a legislation to enforce data sharing, similar to that of RTI, Right to Information Act. By doing so, we can create a rich and accessible data ecosystem that will fuel AI development and innovation. 2, capacity building in emerging technologies. To equip our youth with the skills needed to thrive in a digital age, we must integrate AI into our national curriculum. I have observed that STEM is now a learning area in senior high schools in Ghana, offering courses like robotics and applied engineering that provide essential AI skills and inspire students to generate interest in enrolling in AI-related programs in tertiary institutions and AI careers. We must also develop specialized AI training programs and boot camps to empower young people and unemployed individuals. In addition to the capacity building initiative outlined in the maiden National ICT Week, Kofi Annan Center of Excellence in ICT has also launched the Restart Initiative, aimed at reskilling young people and unemployment individuals for emerging technology jobs such as cloud engineers, that is in the training of AWS, cyber ops in the training of cybersecurity experts. The initiative also offers training in data analytics with Power BI, among others. This initiative has received an overwhelming response. We did the advert for 2 weeks. We got 8,100 applicants. Meanwhile, we were supposed to train only 1,005. But we managed to train about 2,800. So the rest are still there. And this is an area that we are seeking partnership so that the rest can also get skills in order to get jobs. Okay. By implementing these strategies, Ghana can cultivate a generation of AI-savvy individuals who will drive Ghana's technological advancement and contribute to our national economic growth. The last of my suggestions has to do with promoting research in AI. To establish a thriving AI ecosystem, we must create a dedicated AI research center. The AI Research Center will serve as a hub for innovation and collaboration, driving cutting-edge AI research and development. In establishing the new AI Center, I strongly believe that the Kofi Annan Center of Excellence in ICT should be considered due to its proven track record in ICT development in Ghana over the past 20 years. GIKs has also successfully established the Smart Technology Center in Sunyani, an AI research facility that has developed practical AI solution. For instance, we have developed machine learning modules for detecting or classifying cocoa beans. And we have presented the solution to CocoaBot, and they added some other things that they want to see, so we are still working on it. And for the security services, I was happy to see you here. We are working on a GPS-based tracking system that you can put in your vehicle for management of your fleet. In fact, someone came from Germany to this center to do a presentation. At a click of a button, we were able to see all police cars, all fire service cars, all ambulances in one German city. And it has been programmed in such a way that as soon as anything happens, they know which car to move closer to that incident. And that we are seriously pursuing that. This year, the target for the Smart Technologies Center is for them to assemble a drone from scratch. We bought all the parts for them, and they are putting it together, fly it, and then in the coming years, we will apply it to agriculture solutions. In fact, as I speak now, they have tried the first test flight. It went up about a meter. That is the first one. And this one is from scratch, so you have to give us time. Their target is end of year. And I believe by end of year, you will see the Kofi Annan drone, fresh. And okay. The other thing that I want to say is we have to challenge government agencies and universities to contribute to AI development. And I say this because in 1937, Adolf Hitler called a man called Ferdinand Porsche, the man who created the Porsche car, and told that man, I need a car that everybody in Germany who needs a car can buy. And you know that car? VW. It was a challenge given by a government to an individual or an organization. And just like DG was talking about Innovare, I was also thinking, maybe this is a start. In some 10 years to come, we have to see you globally. And then we can say that they are also a company from Ghana. But the point I want to make is that I want to see that government agencies are challenged. Already, NITA is being challenged. And it's good for me to also see that other government agencies are being pushed. But I want a situation where government will call you and say, this agency, come here. This is the work I want you to do for this year. And that work can become a global innovation. And we can all be proud about that. In conclusion, experts agree AI is a critical investment for Ghana's future. The potential benefits are enormous, and the cost of inaction far outweigh the initial cost of implementation. Let us seize this opportunity and build a strong AI foundation for our nation. Thank you for your attention.
Yes, please. Thank you very much. Please, I think he deserves another round of applause. Interesting things about artificial intelligence. So like I was saying earlier, most of us think AI is only ChatGPT, but it's more than that. So I think DG wants to say a word or two, and we'll go on with the program.
Thank you very much. Let's give it up for Kofi Annan. You could tell that Fred is he works for an educational institution. He didn't show us any slides, so he didn't want us to focus on the screen. He wanted us to focus on him and learn and take in what he was saying. But Fred, I also want to challenge you, yeah? Because you want to challenge us. So I want to challenge you. During the tea break, with a few people in the room, some of the speakers in the room, the thought of creating OS came into the discussion. And I said, oh, Kofi Annan has created an OS. To be quite honest with you, I've not seen it. And we are in your home. We are in your house. Eh? So before Thursday, I think is innovation, we will find time so that you can give us a demo. Show us Nyansapo. That's the name, all right? Nyansapo, which is an old operating system that has been created by Kofi Annan. It is important that we see that. Yeah? Creating operating system is not a joke. If they've done it, we should see it, and we should tout it. We should promote it. I understand that it's being used in some of the secondary schools, but we should look at that. There was another thing that you mentioned that I wanted to see, but I've forgotten. But if it comes to me, I'll bring it up. But thank you very much for Kofi Annan and what they are doing. Thank you very much.
Thank you very much, DG. So moving on to the next, we have a team known as STEM Inclusion Ghana. And they are here to talk about IoT. IoT means Internet of Things. And I think there will be some installation of software on various laptops. I have my laptop here. I'll be participating. Who else has their laptop here? Maybe the team can walk to you and help in the installation. Okay. So with a round of applause, let's welcome the team to do their introduction.
All right. Thank you, Kelly. Standing on existing protocols, good afternoon to you all. We are STEM Inclusion Ghana. This is a non-governmental organization, group of people who have taken it upon ourselves to impact the youth and students in Ghana with hands-on STEM skills. I believe since morning we've had enough of presentations. Some of us, when we go for such seminars, at least after we leave, we believe we should go with a skill at least, since we are having National ICT Week. So we from STEM Inclusion Ghana, we are here this afternoon, and we promise that before our hands-on session, each of you here at least will go home having a fair idea or will be able to develop their own prototype. Okay, so I have a lead facilitator here who will be walking us through how to develop a very simple, we've heard of IoT. Our first speaker spoke about that. Mr. Yeboah also did mention of some of what's AI, and then he also mentioned of IoT. But then how about we seeing some of the components? We hear of them, but we don't even get the chance to even play around it, okay? So we here this afternoon to walk you through a hands-on feel of it. And we have a team around. So if you are here and you have your laptop, just raise your hand. They will come to you, install the Arduino software for you. We have some of our components as well. We will give it to you, and then you code along as the facilitator facilitates. Thank you.
Good afternoon. My name is Shaibu Adam from STEM Inclusion. So first, we need to talk about IoT first. So when we say IoT, IoT is very broad. And we know IoT, the short form, that's the short form. And the full meaning of IoT is what? Internet of Things, right? So when we talk about IoT, I'm going to use myself as an example. Let's say myself, Shaibu, from home in the morning, I moved to my office, and at the office, I remember that I've not turned off my AC, right? Now I need to leave my office and go back to my home and go and turn off the AC, right? But with the help of IoT, you don't need to go back to your house and turn off the AC, but you can use your phone to actually turn off your AC, right? So when we are talking about IoT, now we can find IoT in various fields, right? Now we are going to use a simple example as a smart home, okay? So a smart home is whereby everything in your house, or all gadgets in your house are being controlled with the internet, right? So when we talk about IoT also, IoT is we have two division under IoT. We have the general devices and we also have the sensing devices. So the general devices is whereby our TVs, our ACs, our microwaves fall under. They fall under general devices. But when we talk about sensing devices, we have sensors and actuators which actually sense the humidity, temperature, or water level in our room or environment. So when a sensor actually senses a particular object, so let's say we are using a temperature sensor which is going to sense the temperature, so that after the temperature sensor senses the temperature, it sends or transfers the value or data that it has recorded into a gateway. So there is something called a gateway. So the gateway is whereby our data is being processed. Okay, so the gateway also transfers the data that has been processed into the cloud with the help of a Wi-Fi, right? So when it goes into the cloud, so that's where the cloud also gives us information of what has been recorded, maybe the level of temperature in our room on your phone. Okay, so let's say you have all this recorded on your phone. You know that, okay, so this is the temperature level in my room, right? In the same way, if you want to actually control your televisions as well, so you've turned on your televisions with your phone, you can also turn on the television with your you can also turn off the television with your phone as well. Now, I know some people have Alexa and Google Assistant at home, but most of us actually use it to play music. But those devices can also be used in a IoT field. Okay, we can use the Alexa to control, so something like a voice control. We can control our lights. So you wake up and you just say, Alexa, hey Alexa, turn on my light or turn on my bedroom light. Then your light is going to turn on. The same way you can tell it, hey Alexa or hey Google, close my window, and it's going to do that, right? So where the sensing actually picks the data that it has recorded, then sends it into the gateway. So the gateway might be your controller, okay, or your microcontroller that is going to process the data that it has picked from the sensor. Then it's going to send it into the cloud, right? So we are going to have an example of a smart system using Arduino, okay? So we are going to do something practical right now. So please, if you have your laptop, you can actually, my teammates are around, you can actually raise up your hand. They'll come and install the application or the IDE in your laptop. Then we can actually proceed with what you're about to do. So we are going to work on we are going to look at how a smart street light works. Okay, so we know the smart street light, it turns on in the evening by itself and goes off daytime by itself without you going to turn it on and off. Okay, so we are going to have a concept here in a practical way so that we can understand how the smart street light actually works. Okay, so the phone version. No, 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 no. No. So before you can, though we have the phone version, the ID, we have the phone version, but you need an OTG. Because you are going to make a connection between the controller and the phone. Okay. But the laptops already have the USB port. So you just connect it straight to it. Okay.
For now, or like you can't demonstrate that now, or we don't have a phone version.
The phone version.
Yeah.
No, the phone version, unless you download it from Play Store.
But there is.
Yes, there is.
Me, I don't want to hear no, it can't be done.
There is.
That's why.
There
Thank
is.
you.
All right. So before we actually proceed into our hardware part, first we need to look at the software. Okay. So we have the software part of our project. Now we are using C++ to actually code our system. Now when you look here, we have a series of statements here that has been written. Okay. So we are going to use a sensor called LDR. Okay, so this sensor actually senses the light intensity in the room. Okay, so it can pick the data of the. So let's say now it's daytime. So it's going to pick the light intensity into a data form. So let's say something like 600. Then it's actually going to send it into the Arduino board, which is the controller itself. Then it can actually tell the system what to do. Okay, so we are going to use the LDR, which is the sensor. We also have an LED. So the LED is actually going to turn on as our output.
IoT is a very interesting concept, and it's here with us.
Yes.
So explain yourself well, because I'm following your code.
Sure.
The LDR is a sensor, you said.
Yes.
So what are the parameters that you get? Why have you assigned 8 to the LDR? What does 8 mean? Within the spectrum of 1 to whatever, 10, what is 8? So explain those things.
Sure. Okay. So before we move on, so this is how the LDR looks like. I think, all right. So my team is actually sharing the kits among those who have the laptops. So when you open it, they will show you how the LDR looks like. Okay, so this is an LDR model. So LDR actually means light dependent resistor. Okay, so light dependent resistor. That's what the LDR means. Now the first line of code we have on top, we have int LDR is equal to 8. Then we end it with what? A semicolon. Now, the first thing we have here, when you are writing a message or you are writing a letter to someone, the first thing you need to do is what? You need to actually write the address of the letter first. So before you type your code, you need to have the address. Okay, so the address that we have under our code is this one. So the ones with the int. So we have int LDR, which is equal to 8. We have int light. We also have int LED is equal to 9. So these ones are the address. So it's like the declaration, declaring each component that you are using in your system, or mentioning each component that you are going to use inside your system, the name of the component, and the pin or the signal pin that they are being connected to. So the first one that we have here, int LDR, is equal to 8. Now, we are actually telling the IDE that our LDR is connected to what? Pin 8 on the microcontroller, right? And Under Arduino ID also, you know, in English, when you are making a statement, so Amma is going to school, you end it with what? A full stop. But C++ doesn't go with the rules of what? English. Instead of ending your statement with a full stop, you actually end it with what? A semicolon rather. Okay. So when you end it with your semicolon, which means your statement has been ended, you don't need to add anything behind the semicolon, right? Now the second line is what? Int light. Then we end it with a semicolon. So we'll come back to that one. For now, let's leave the second line. Let's move to the next one, which is int LED is equal to 9. Then end it with a semicolon. Now we are also going to use the LED. Okay, since you are going to use the LED, we need to tell the system, or we need to declare the pin of the LED, which means the LED is connected to what? Pin 9, right? So now we've actually declared everything you are going to use in our system. So the next thing we need to look at is what? The void setup. So the void setup actually means typing your code to run once. That's the meaning of the void setup there. So when you type your code under the void setup line, so the void setup and void loop, they are always constant or default. Anytime you open your applications, it's there. Okay, it's actually default. Anytime you open your application, void setup and void loop is always there as default statements or functions. So when you look at under the void setup, we also have a comment under it, which says put your setup code here to run once, which means when you type your code there, it's actually going to implement once. Okay, but when you look at the void loop actually says put your main code here to run repeatedly. So we know the meaning of loop. So when you enter your code under the void loop, your code is going to run repeatedly. So let's say you are turning off, you want to turn on and off a light. So when you type it under the void loop, it's going to do what? Turn on, off, because it says put your main code here to run what? Repeatedly. Okay. So let's go to void setup. Under the void setup, we have serial.begin into bracket 9600 bracket close. Then we end our statement with a semicolon. So as you can see that each line of code that we actually type, we end with the what? A semicolon, which means it's very, very, very important. When you type your code without a semicolon, which means when you are verifying your code, it's going to tell you that there is a mistake somewhere. So anytime you type your code, you need to end it with your semicolon, right? So the serial.begin here means, now when you look up here, we have a button there with the search tool there. Okay, so that button is actually called the serial monitor. Now, as an engineer, when working with any sensor, before you actually implement the sensor into any system that you want to work with, so before you actually put your sensor in it, the first thing you need to do what? You need to test your sensor, right? You need to test your sensor. So the first thing we are going to do here is what? Test our sensor to actually see that our sensor can actually give us the data that we need. Okay, but when you actually check the sensor and you don't get the data, which means your sensor is not what? Working. So the first thing we need to do is what? We are going to open our serial monitor. So that's the serial monitor. So the serial monitor is actually our tester to test our sensors, to actually see that, yes, our sensor is what? Working. So for us to activate the serial monitor, the first thing we need to do is what? Serial.begin. So the name of the serial monitor, so begin here means the serial monitor should what? Activate, or it should begin working. Now the 9600 that we have in the bracket is the storage that the sensor can actually contain. Okay, so when using, we have basic sensors and we also have advanced sensors. Okay, so the basic sensors that we have, they actually use 9600 as a storage. Okay, but the advanced sensors also have their board number. So this is actually called the baud number of our serial monitor. Okay. Now the next one that we have is what? P mode, LDR, P mode into brackets, LDR, then input. Now, the pin mode there is what? We are actually activating the pin whereby we connected our LDR, okay, on the Arduino board or the microcontroller. So we are going to activate our pin. Since we are going to activate our pin, we need to mention some important things under the LDR. So we are telling the system that, okay, we are working with the LDR. And the LDR is which type of component. So in ICT, we have output devices and what? Input devices. So we need to tell our system that sensors actually pick data and send it into the Arduino board or the microcontroller, which means our sensors are always what? Input devices. Okay, so they are always input devices because they pick and send. They don't actually give us the information. They rather pick and send into the microcontroller. So anytime you work with a sensor, you need to what? You need to tell the system that your sensor is what? An input component. Then after you close your bracket, then you end it with your semicolon. Then the next thing we have is what? Pin mode LED. So we are activating the pin that we connected the LED to. So the LED was connected to which pin? Pin number 9 on the board. Okay, so when you connect, we are activating that pin number 9. Now, LEDs, actually, we can see what the LED does. It actually turns on. So as long as it turns on, we can say what? The LED is giving us an output information, right? So we actually categorize the LED under output devices. Now we are done with the void setup. All this code that we have here is going to run once. Okay. Now the code is going to run, is going to read in lines. So after reading this, it moves to this, it moves to this, but we can't see it reading. But it's reading in lines. Now let's move to void loop. So under void loop, we have what? Put your main code here to run repeatedly. Now we have light here. We actually declared light up there, but we didn't know what the light is doing there. So under the void loop, we are going to tell our system, which under the void loop, which is containing the main code, we are going to tell our system that, so the light that we declared, the light here is equal to what? The LDR, because the LDR is going to pick the light intensity in our room. So the light here represents the value that we are going to pick from the room. Okay, so the light here is representing the value that we are picking from the room. So which means our LDR is going to read the values and send it into the Arduino board. So light, which is the values that we are going to pick, is equal to the what? LDR. And the LDR is what? Is going to read the so when you are connecting I'll explain this side, the digital read to you when we are doing our connection. Now let's go to our main system, our main code that is going to what? Actually activate and off our project. We have what? If. So the if is a statement that we have here. So the if statement actually is like a communication between you, the user, and the what? Your system. So you are going to actually type something. So if this and this happens, this should happen. So, or I can say, if Shaibu, I touch you, you should run away. So that's how the system actually works here. So we have what? If. So if into bracket, light is what? Less than, is equal to 1. So which means the light that we are recording, the value that we are recording is going to be 1. Okay. I'll explain that when we open our serial monitor to check the lights that we are going to record. Now, under it also, we have digital right, LED should be high. Okay. Now, we are telling the code that, you are telling the ID that if our LDR senses an amount of light at, which is what? 1, the digital right, the LED should what? Turn on. It should high. As a human being, if I'm sending someone to go and turn on the light, we actually tell the person that, okay, Kofi, go and turn on the light. Then Kofi will go and turn on the light. But our system doesn't understand what turn on the light. So what it understands is what? It should write something. So that write that is going to happen is what we are going to see the LED doing. Okay, so instead of we saying do this, we are rather telling it that it should what? Write this. So when it writes that, actually, when the system writes, that's where you are going to see your LED what? Turning on at high. Okay, so the opposite of high is always what? Low. So whenever, now we have else here. So the else here means when nothing is happening. So if light is equal to 1, LED should what? Turn on. Else, when nothing is happening, the LED should what? Go off. That's where we have low here. Okay. So let's move to this side. So serial.print ln light. Now this is where we are going to print our data from the sensor into the what? The serial monitor. Okay, so after we are done with the connection, I will explain that so that we can understand what we are going to have on the serial monitor. So please, do we all have our IDE installed on our laptops? Okay. So please, those who have the kits, I want you to pick this component. So this component is called the breadboard. Okay, so the breadboard, actually, we make our connections on the breadboard. So when you make your connections on the breadboard, you can actually take it off and actually do another connection on the breadboard. So you don't need to solder or do a permanent work on the breadboard. You can actually make a temporary project on the breadboard. Then you can actually take it off in future. Now the next thing we have here that we are going to pick is the Arduino board. So this is where our processing and everything happens. Okay, so this is the brain of our project. So this is the brain where the processing of our data that we are going to pick from the sensor goes into processes and actually tells the LED what to do. Now, we also have the LDR. So this, the LDR. Now the LDR, this one is the LDR model. Okay, we have the LDR itself is what is on top of your model. Okay, so the model is used to regulate the light intensity that the LDR is going to pick. Okay, all right. So the next thing we are going to also look at is our wires. So these wires are called jumper wires. The reason why they are called jumper wires is because we jump them from one component to the other. Okay, so when you connect it here, you need to jump it from the breadboard to what? The Arduino board, so that you can actually have a communication going on between the what? The microcontroller and your breadboard. Okay. So the first thing we are going to do is connecting our LDR onto our breadboard. Okay. So when you have the breadboard, I want you to hold the breadboard in a horizontal way, this way. Those who have the breadboard, I want you to hold it in a horizontal way. Now, you are going to connect the LDR to face you. Okay, so this where is going to face you, this side of the LDR. So when you connect it, you are going to connect it this way. So it's going to face you. Okay. Please, my colleagues, make sure you are going around checking that they are doing the right thing. So make sure that the the LDR is actually facing you. Yeah, you can do it anywhere. Okay. So this side. Yeah, this side. Yeah. Yes. So we are actually going to now. Our LDR has 3 pins. When you look at the LDR, it has 3 pins. It has what? The VCC. It has, when you look on it, it has been labeled VCC, GND, and DO. Okay. Now VCC actually means voltage common collector. it actually explains itself. It's where the voltage is being what? Collected from the Arduino board, okay, to supply voltage to it, okay. So it's always connected to 5 volts on the Arduino board. And GND here means ground. We always know that ground represents what? Our negative. So the GND here means ground, which is our what? Negative. Now the D0 there is what? Our signal pin. So the D0 is always connected to the signal pin of the what? Arduino board, which actually gives us the signal communication between the LDR and the what? Arduino board. Okay. So the next thing we are going to do is what? Connect our jumper wires. So make sure that you are connecting your jumper wires right behind the pins of your LDR. So the pin, so let's say when you pick your jumper wire, the VCC should be parallel to the pin of the pin of the jumper wire. Okay. So I'm going to do that and show you. Okay. So you can see that my wires are right behind the what? The sensor. Okay. So when you make it this way, which means you are doing the right thing. But if you now when you look on the breadboard, you can see a bridge in between the breadboard. Okay. So that bridge there, when you move your jumper wire from this side, so you can see this one is one side and this side is also another side. Okay. So when you move your wire from this side to this side, it's not going to work. Why? Because the bridge in between there is no connection between this part and this part. Okay. So anytime you are doing your connection, make sure that your wires are always close to your what? Your component. They are not far from your component, so that you can actually have communication easily, okay, or flow of current easily. So please, are we done with that? Okay, correct. Okay, correct. Please, who else? All right. Now, the next thing we are going to do is what? We are going to connect the other end of our what? Jumper wire to what? The Arduino board. Okay. Now, when you look on the Arduino board, we have digital. So digital is from 0 to what? 13. Okay, so those are the signal pins, 0 to 13. Now, when we come back to our code, you can see that the LDR was connected to what? Pin 8. Okay, so that's the signal pin or the digital pin 8 that the LDR is connected to. And the LED is also connected to what? Pin 9. Which means we are going to connect our LED to what? Pin 9. But for now, we've made the connection for what? The LDR. So we are going to pick the D0 of the LDR. The wire connected to D0. We are going to connect it to what? Pin 8 on the Arduino board. Okay. So I'm going to do that now. So I have it connected to D8. We can also mention it as D8, digital pin 8. Okay. Now, when you look at the other end of your Arduino board, we also have power pins and also analog pins. Okay. Today we are not going to make use of the analog pins. We are going to make use of the power pins. Okay. Now the power pins, we have VIN, which means voltage in. We are giving voltage to the what? Arduino board. Now we also have what? GND, which is our negative. Another GND, which is our negative. We also have 5V and 3.3V, which means 5 volts and 3.3 volts. So we are going to pick those voltage and supply it to what? Our sensor or any component that we are going to connect on the system. Okay. So the VCC, the wire connected to VCC, you are going to connect it to what? 5V. So pick the wire that is connected to VCC to 5V. So these are the power pins. The power pins.
1, 2, 3, 4. The fourth.
Yes, correct. Okay, now the wire connected to GND to GND. So GND to GND, negative to negative. So I think there is GND right beside the 5V, right close to the 5V. Please, are we all okay? Okay. Now we are going to move. We are including what? LED. So we need to also make connection for the what? LED. So for now, you can see that we are making the implementation of the hardware side. Now, when we look at the LED, LED has what? Two terminals or two legs. Okay, the longer one and the shorter one. Okay. Always we say the what? The longer one is our what? Who can tell me the longer leg, what it represents? The LED. The longer one is what? Okay, I'll pick that. Who else? Who else? Please, who else? The LED has two terminals. One is GND and one is positive. So which one is positive and which one is GND? Or which one is negative? Yes, so the longer one is what? The positive, and the shorter one is what? The negative. Okay, so please, let's put it in our mind. Anytime we see the LED, the longer one is always the what? Positive, and the shorter one is always the what? The negative. Okay, so the same thing you did for the LDR, you are going to do the same thing for the LED. Okay, so you are going to make the same thing for the LED. So one leg at one line, another leg at another line as well. Okay, good. This way. Yeah. This way. Okay. Yeah. So you can connect it anywhere on the Arduino board, but make sure that one is at one line, another one is also at another line, okay? All right. Now, we are going to pick two jumper wires for the LED, okay? So, the same thing, one jumper wire right behind the what? One leg, another jumper wire right behind. Please make sure that you know where your positive is being connected to and where your negative is being connected to. Please, are we done? Okay. So, this is how we are connecting it. So one leg right behind the one leg and the other leg also right behind the negative leg. Okay. Oh yeah. So please, now when you are done with the connection on the breadboard, now the wire connected to the positive, which is the long leg, should go to digital pin what? 9, because that's what we are using. So it should go to the positive leg, should go to digital pin 9, and the negative leg should go to what? GND. Okay, as we said, GND is always our what? Negative. Okay, I think we have about 3 GNDs on our board. So we can use the other GND. So the positive wire to the digital pin 9 and the negative wire to the GND. Okay, so when we do that, we are done with the connection. Okay, so I have already uploaded my code on the Arduino board. So when you connect the Arduino board to your computer or your laptops, the two LEDs on the sensor should what? Turn on. Okay, so I'm going to make my demonstration. I've already uploaded the code. So you can see that when I try to form darkness on the sensor, then what? The LED turns on, which means it's nighttime. But when I take off my hand, which means it's what? Daytime. So the LED goes off. So I'm going to do the demonstration again, which means it's nighttime. So LED is what? Off. It's on. And daytime, our LED automatically goes off. Okay. So you should have something simple like this, which is representing the concept of what? A smart street light. Okay. So please, I want to see who is done with DS. The cable. So the first thing you need to do after connecting your Arduino board to the computer is what? You move to tools and you select the port number of your Arduino board. Each of you have a different port number. Someone can have what? Port number 5. Someone can have port number 6. Someone can also have port number 13. Okay, so you need to go to the port from tools. After selecting the port, then you are good to go. Then you come, you verify. After verifying, then you upload the code into your. Okay. Tools. Yeah. So board 7. Com 7. So yeah, com 7.
Now the libraries, you can see that the inputs and outputs are not registered. Do we have to get a library?
Okay. So there's compilation error expected unqualified until before. Okay. So remove anything. So the reason is because when you only typed int is equal to 9. So you need to type the LED there first. So another this means compilation digital. So the right W is in capital letter. Yeah. So please, we also have, when you look at our code, we have some statement that what begins with what? Small letters, and within the statement, we can actually see capital letters. So this is called camel casing. We know how the camel looks like. Okay, so we begin with a small letter, the P mode. Then the mode, we actually continue the mode with what? A capital M, which means the pin and the mode is a compound word. Two words, two separate words coming together, which means they are compound, it's a compound word, okay? So the P begins with what? A small letter, and the M begins with a capital letter. Same as digital right. The D begins with a small letter, and W is what? Capital, okay? But the serial, the S is what? Always capital. And when you begin with a small LDR, in small letters, make sure that each line of code where LDR is being typed, you actually represent it what? The small letters. Okay. Anytime you begin with a small letter at the declaration side, you make sure that you repeat the small letters among the code. Okay. When you begin with capital letters, anywhere you see LDR, you what? Begin with the what? Capital letters. Okay. So please, any confusion or any question? Okay, so
Compilation was okay. There were no errors after compilation.
yeah, no, not yet.
We continue and build what? A whole lot of what? Prototypes. So this, let's take it to our homes, okay? I have been to MOC. When you get to their corridor, the light comes on because it has sensed that there's a human being here, right? But then once you move out, it turns off. So this is one of the approaches, okay? It can also be seen as a smart street lights. We don't have to on and off. So by doing so, we are conserving what? Energy. As in when it's needed, it has to do what? Turns off. And this is very smart. Okay, so these are some of the things we at STEM Inclusion Ghana, we believe in. And within this shortest time, we've been able to come up with what? A simple prototype. We move from schools to communities, organizations, and what? Churches. So you can hit us up on Instagram as STEMINCGH. And we have a website, stemmingGH.com, or I am with Kofi Annan. Once you come here, just ask of Annette, you reach me, and then we will come to your doorsteps and give you all the necessary training you would require. Thank you.
I think please, let's do better for them. Okay, thank you very much, Stemming GH, for that interesting training. DJ and I did our own. Ours is still working. Yes. So we are engineers. Please clap for us. Okay, so please, how many of us did this exercise? I want to see those of us who did the exercise. Okay. No team member here? Nobody here? Okay. Is your code working? Oh, you're still working on it. Okay, okay. All right. Okay, so I think this brings us to the end of today's session. Tomorrow, okay, again, I would ask one word for this session. Excellent. I like that. Excellent. What else? Interesting. Okay. Practical. Innovative from Innovari. What else? Smart. Okay. What? Possible. It is possible. Okay, okay, great. So today was more of a practical session. As you can see, some of the members are still trying to get their lights on. Sorry? Okay. You want to make an announcement?
Let me just. Okay, so I'm giving out my contact since I might not be able to move from one person to the other. So the number is 0247 45 34 61. I take it again. 0247 45 34 61. Annette, STEM Inclusion Ghana. Thank you.
Oh, and to add, Annette was my mate in Ghana Telecom, so we are sharp people. So please give us a round of applause. All right. So thank you very much. Tomorrow we are going to be having the Digital Trust Conference, and we have some interesting things to talk about tomorrow about digital trust. How do you trust whatever you are doing digitally? That's the conversation that we're going to have tomorrow. I'd like to thank all of you for coming today. My name is Kelly Atichogbi. I'm with the National IT Agency, and I wish you all a fantastic day.
Thank you very much for coming once again. Tomorrow is an interesting day. Please, if you've been coming, don't miss tomorrow and don't miss Thursday. Tomorrow is a conference within the ICT week. We have a session on PKI. For those who don't know, PKI is public key infrastructure. Public key infrastructure is what is really behind encryption and authentication in all the things we do. So every Ghana card that you have, or anyone who has a Ghana card, we certify the card that is original and it's not fake, all right? So tomorrow we have e-Imudra. My colleagues wanted to surprise you, but I'm telling you, they've just arrived. They're coming from India, and they are the biggest PKI implementers in India. In all the stuff that they are doing, they are behind it in India. They are here. They'll join us tomorrow. Tomorrow, the Honorable Minister would also be here to make a policy statement on PKI. So please, let's endeavor to come on time. We gave her 9:40 to about 10. I know we've been starting at 10, which is fine because sometimes we have to get here. But by 10 o'clock, please, let's be seated, and she'll be here, and we'll have a great conference. In between, there'll be a panel discussion and all that. So look forward to seeing you tomorrow. Please, let's go and have lunch. Yeah?
So please go with your chat.